Welcome to CTO Insights, where we unpack the strategies behind high-performing engineering teams. I'm your host, Katerina, and today I have the pleasure of welcoming Bryan Finster, co-creator of Minimum Viable Continuous Delivery. In this episode, Bryan shares a practical, step-by-step approach to implementing continuous delivery in legacy and enterprise environments. From getting buy-in to improving test coverage and team structure, we explore how to drive real progress without needing a complete rewrite. If you're dealing with slow, manual releases and want a clear path to faster, safer delivery, this episode is for you. Stay tuned and don't forget to subscribe for more insights into creating high-performing teams and standout products. This episode is brought to you by Adiva, a global network of top developers connecting businesses with world-class talent. Whether you need to scale your team or bring an idea to life, Adiva empowers you to increase your engineering capacity without the overhead of traditional hiring. Visit adiva.it to learn more. Bryan, welcome. Thank you for joining me today.
Thanks for having me.
Let's start with the why. Why continuous delivery in terms of what are the real benefits to the business to make the investment worth it?
I think it's important to understand my history with it, because the first exposure I had to continuous delivery was when we were asked to solve the problem from our SVP that we were only delivering every quarter with a time of 12 months on any reasonable feature. And every time we did a deploy, you'd have at least a week of 24/7 in the office support, really a lot of instability, terrible quality. We were always running late. We were aiming for every quarter. It usually ran about 6 weeks late due to merge conflict resolution, and it was just terrible. And so he said he wanted us to deliver every 2 weeks. And let's just do that every 2 weeks. That's fun. Instead of hiring consultants, he just asked us, the senior engineers who had figured it out. And one of my colleagues grabbed a copy of Continuous Delivery, and we just started using that as our Bible. And it was funny, I had a project manager assigned to our Tiger team to help us organize this. Now, we're both senior engineers, been doing this. We had decades of experience between us. We said we're going to go for daily, because every 2 weeks is not often enough to really get the benefits that this book is saying that we should see. And he threw a fit, said, I'm not signing up for that. We're going to fail. And so we said, okay, don't sign up for it. We're signing up for that. And so we started driving towards that. Fast forward to the point where the team that I'm on, we're delivering multiple times a day to production. And I'll tell you, it was a journey. I wrote an article for InfoQ about that journey. It was a long journey. But the benefit to that was that not only could we turn a feature request around in days, or even sometimes within a day, and get feedback directly from a distribution center to say, hey, what do you think about this? Our quality was higher. We weren't getting hammered with pager calls, and the team morale was higher. And that's really the team morale thing is why I talk about this so much, because the experience we had was that every team that was able to do this, and later I had the job at Walmart of teaching other teams how to do this across the enterprise. And without exception, every team that was able to get started on this and get past just the hump of continuous integration and moving towards continuous delivery had better team morale, just better quality of life. And it's better for the business because we can turn things around faster, get faster feedback, and use less work to deliver more value. But it's better for the teams because it's just a better way of life.
How long did it take to go from that initial state? You said you were deploying once a quarter, right?
Yeah.
To multiple times a day.
I think, so this is a while back, but if I remember correctly, to get the first few pilot teams up to multiple times a day. And so you have to understand first, this is a very large warehouse management system with 25 million lines of legacy code with no tests. And it wasn't just, hey, you guys go deliver more rapidly. It was, okay, let's run Strangler on this. Let's break this thing up into business modules that we can deliver independently. and then let's do that better. It took about 18 months for the first teams to get to where we were able to deliver at that sort of speed. And I'll say that we didn't ever get done. This is the warning I have for people who said, "Oh, we'll just run Strangler on our legacy application." If it really requires long-term leadership vision and continuity for that to happen. We had a leadership change, the strategy changed, and we never finished strangling the application. So we only had a few of the modules peeled out, and then we had everything else was this giant, terrible, awful thing.
Speaking of the context of the project, so we have multiple scenarios, multiple different variations of projects going from the average web application. And then when we were discussing about this episode, you mentioned what does continuous deployment mean in terms of government projects and burning code to physical cities, and even not going to that extreme, speaking of mobile apps, for example, where you cannot as easily push new code to users all the time. What does continuous deployment mean in each of these cases?
I think there's a distinction people need to make between continuous delivery and continuous deployment. Number one, people sometimes get those two things confused. And continuous delivery means that we're always in a state where we can deliver the latest change on demand, which means that whatever change I'm making right now, when I push that to version control, it will get fully validated and say, okay, this is either deployable or this version of the artifact can't go to production. And then we can release that on demand, whether that's pushing it to an app store, pushing it directly to an end user, or burning it to a DVD and taking it to a secure network. Continuous deploy means that when I push that change to version control, if the pipeline says it's good, it will then go directly to production. And so those are continuous deploy is a really good thing for some software supply chains. It's not viable for other software supply chains. You're not going to do continuous deploy to the App Store for Apple because Apple has to go and do all their certifications. So there's that overhead. So I come from supply chain software background. A supply chain background. So I look at this as just a software supply chain. So it's what are our different delivery contexts and what is the correct tool to apply to those contexts?
Okay, yeah, makes sense. And speaking of the minimum requirements to actually start doing continuous delivery, you are one of the creators of Minimum Viable CD. What are the minimum requirements a team has to meet to, go in this direction?
And again, I think the history of why we put that together and what the goals we had of putting that together were is important. Number one, we were hearing all these people saying we've done CD and it just made things terrible because we were just exploding things in production. Or we tried CD and everything blew up, our management banned continuous delivery. Or I'm doing CD because we deploy on demand and that's the definition and our customers only demand it once a month. No, you're not getting your feedback loops that way. And based off of the experience that I had with CD makes our lives better and improves the organization communication structures. You can't do CD with terrible communication and functional silos. And so you have to fix all these things to get to continuous delivery. And so the goal that we had was, let's put together a list of the absolute minimums that qualifies for continuous delivery that works in every delivery context, including a submarine. That are challenges that you can say we're either meeting this challenge or not meeting this challenge, that to do these, you have to fix things. You have to fix things in your organization. And so that was really the goal. The first one's continuous integration. And we define what continuous integration is. You're doing trunk-based development or integrating code very frequently, multiple times a day. And where everything is tested before it goes into version control. And then the automation runs and validates the tests, validates that you're testing correctly. There's only one way to deliver anything, and that's application pipeline. You don't have exception flows. You don't have a hotfix process. Except the way I communicate it is we only have the hotfix process. We have our emergency process, and that's what we use every single day to deliver change so that we know our emergency process works. So in an emergency, we're not making it up. When it's an emergency, the last thing we want to worry about is how do we deliver this safely? And so we only use our emergency process. Another really important one is that the pipeline is the only arbiter of releasable. That it's the thing that validates everything, and all of our validations are in there. And that's functional testing, performance testing, security testing, compliance testing, anything. Now, that's a big challenge. A lot of people rely a lot on manual testing. And so the answer is, okay, so let's start peeling apart what we're testing for and how we can make that automated so we can do it cheaper. Because that's another big benefit, is it lowers the cost of change. If I can deliver things cheaper, then it's easy for me to try something and throw it away if it doesn't work. It's a huge business benefit. Immutable artifact. If we build an artifact, we start testing it, and something fails halfway down the pipeline, we don't change the artifact to make it pass the test. We throw it away and we start again from version control. We just never update the artifact. If the pipeline turns red, we as a team stop and fix the pipeline, because our pipeline is the only way we have to validate our work. If we can't validate our work, why are we piling more unvalidated work on top of it? Let's stop and fix the pipeline to make it turn green, and then start going back to work. It's just an important team behavior. We need production-like test environments. It's no good to go and test on my machine and then go test a dev environment that doesn't match production at all, and then eventually go to deploy it to production. I was talking to a Marine product manager where they'd done all this work in a dev environment for 6 months before they were able to go to production, and only to discover that the production environment had a dependency version that they needed. There was a lower version, and it was going to take another 6 months, 12 months to get that version upgrade approved. And so their software couldn't even work. It just wouldn't function at all in production because they weren't testing with what production looked like. Being able to roll back on demand. And that could either be we're doing blue-green deploys, we deploy to one environment, it fails, and then we swap back over to the good environment and then revert the old environment. It can roll forward as an option for rollback on demand, but have some method where we can run tests quickly and then revert back to a known good state. And then application configuration is part of the artifact. It's not some other thing. You have to test all of that together as a thing. It's not just the code. It's the environment, configuration, everything is what we're testing. So those are the minimums. So those are hard problems to solve. But once you solve them, even going down the path of trying to solve them makes your organization better.
Yeah, I like to dive into the incremental steps we could take to get there, because especially with legacy code, enterprise environments, a lot of dependency on manual testing and quality verification and everything. It is overwhelming, to say the least. And it's difficult to sell it to stakeholders. The first question there would be, how do you make the case for CD with the leadership in an enterprise environment where the process took 6 months and now you want to do it once a day and it requires a massive change in the whole structure? And then once you do it, what are the step-by-step actions we can take to do that?
I'll say frankly, if no one sees that there's a problem, then it's really hard to sell it, because it seems like extra work, and there's work involved, but it's the same work as like making your car run better. It's just the thing you do to make your business run better. And the way that it got sold originally in logistics it was a crisis. We just couldn't meet our business goals with the way things were going. We had to fix it. And Safe sure as hell wasn't doing it. It was only making it take longer. And so let's go and try this. I'll say that because you can incrementally get better over time, it's not an all or nothing thing. It's like, let's start with, why can't we do continuous integration? And you value stream map your delivery flow, and you go and look at where all the problems are, and you start fixing the problems. And you can filter those in over time and start solving those problems. Now, if you have a big legacy code base like we had, one of those problems is you have a big legacy, big ball of mud that's really hard to separate out and deliver incrementally. You have to deliver the whole thing as a version. It's very hard to do CD that way. And then you start looking at, is it more expensive for us to keep doing this? Because we have all this, frankly, if there's no change going on, don't bother. But if we're changing this thing all the time, which we were, it's really expensive to try to operate that way. So let's peel out the thing we change most often, and let's start working on doing continuous delivery there and improving the quality process, because CD is a quality process, not about speed. It's about improving quality, improving feedback, right? So let's just peel out that, make that better, and let's see how that goes. And if we like how that goes, then let's go peel out the next thing that we're changing frequently and make that better. If you're left with a core that you're not changing at all, don't touch it. You'll probably break it. But be pragmatic about it. But you will make it easier to deliver the things that you're delivering frequently.
How did you go about continuous integration with this code and testing the legacy? Did you have any strategies of working with existing code that is maybe integrated with the thing you are changing off, and this piece of code is still stable and should not be altered that much?
And the suggestion I always have is only add tests to the code you're changing, number one, because at least you have some expected behaviors that it's supposed to do. So you have a requirement that's when we're done, it should work like this, right? And that way you know what to test for. But if you have something that you're not changing and you go and add tests to it, you'll test that it's working the way it is, but you'll be testing implementation. You don't honestly know how it should behave. You just know how it does behave. And so writing tests for that doesn't really help you. And if you're not changing it, those tests aren't helping you either. Those tests are there to make sure that you can change it safely. And so peel out a chunk that you're going to work on and find the edges of that change and then test for those new behaviors. And that's how you should start. As far as continuous integration goes, where we're integrating that code frequently all the time, what we did was we literally put up, I wrote down on a piece of paper, why can't we do continuous integration? And then I wrote the rules down for continuous integration. And then my team and I just worked through what the problems were. And honestly, the first problem and the main problem we had to solve was the requirements were garbage. And this is something that developers gripe about all the time. But how did you fix it? The way we fixed it was behavior-driven development, where we got the team, including the product owner and the QA lead together, and we defined the testable behaviors on paper that this new feature should do. And then now we had a list of tests that all we had to do was do acceptance test-driven development and make sure it did that, which made coding and implementation detail not the main work. The main work was deciding what to code. And that accelerated things dramatically. That one thing was such an improvement that I started going around the broader organization. This is when I first started learning how to give talks. And I'd go to different areas and say, I'd love to tell you about this cool thing that we're doing that's making it so much easier to deliver software. And can I come talk to your teams about it? Because it's amazing. Because part of it was if I could spread the infection, it'd be a lot harder for the local management to kill it, right? Because it would be happening in other areas. So right, how do I affect other people? But it was a dramatic improvement. I tell people always start with behavior-driven development because that'll show you where your communication problems are for getting good requirements. And then it'll teach people how to test if they don't have the skill.
Did this also change the dynamics between the product team and engineering, like how they collaborated to define the requirements, the criteria, or was it still mostly on the product side?
No, so I'll say that there was this convergence of changes that were happening that made this a little bit easier. One of those was that they disbanded all of the feature teams and reorganized the Scrum product teams. And that's one of the changes we're making. We're streamlining the application was that we're going to form these product teams. And so the team that I was leading, we were just in charge of receiving freight. So there was that one business capability of the warehouse was receiving freight. And so we had a business product owner assigned to the team. Now, yeah, the dynamic absolutely changed because originally I thought their role was to write stories and hand them to us. And suddenly they had to become team members and collaborate with us to make sure that we had good acceptance tests. And so they started feeling like team members.
Makes sense. And speaking of the practical side of organizing the code, after you started with the requirements specification and making sure that you have all the needed details to execute on them, how did you go about reorganizing the pieces of the legacy code that were changed frequently?
So part of it was that we were writing, there was a new like GUI user interface we were creating because it was green screen. And so we had some new code that we're generating. We also had a bunch of backend new behaviors that were needed. So that was all brand new code. For legacy code that we had to interact with, we dropped just a REST interface in front of it so that we could interact with it through a REST interface instead of like direct database connection. So we started decoupling with interfaces and to peel it apart that way. So it was a combination of writing new code to replace code that we didn't want to, that didn't know we needed to do, and then adding interfaces for the code we did.
Okay. And did you do any like other changes within the organization, the teamwork, or anything else worth mentioning at this
The
point?
main thing is we're organized around long-lived product teams instead of the short-lived feature teams. I always rail against those. Those are terrible. We took back control of our operational support. When I started my career, I was in charge of fixing the code that I wrote when it broke in production in the middle of the night. So that encourages not breaking things. The same thing was true when I started working at Walmart back in the early 2000s, that we were operational support. Then to improve developer productivity, they split out product, ops, and coding as the three different silos. And we no longer had primary operational support, which is terrible in many ways. I'd love to have a conversation about why that's bad, but I don't want to go into it. That's a long story. But when we started doing CD and we were able to deliver that frequently, we couldn't meet the SLA for the handoff to ops, which made me happy because ops didn't want to collaborate with us to be how can we do operations better to get faster feedback. Don't change our code, wake us up. They didn't want to do that. Our contract won't allow that. Cool. But since we couldn't meet their SLA, we are automatically supported because we could never get to their 90 days of stability because we're always changing things.
And speaking of metrics, so once you have all of this in place, I read somewhere in your blogs that, and I think you mentioned it now with the organizational change at the company where you first started with putting City together, the management changed and the new leadership wasn't able to understand the impact of CD on the business and the process and everything. So metrics are very important to get together and get them right. How do you measure the impact and how do you show the leadership that, this is why this is important?
Number one, you have to make sure that you have a set of metrics that they actually understand why they mean something. I think there's Adora metrics that become really popular. I'm one of the people who was pushing that in the industry, and I regret it because people don't really understand what they mean. I know what they mean because I know what they indicate. I also know they're lagging indicators that don't tell us what's right. They just tell us what might be wrong, but not why. It's like they're as useful as like check engine lights on your dashboard. They're just exactly that useful. If I'm talking to somebody that's looking at it from a business perspective, I want to talk about how fast can we get to value. I want to talk about how much it costs for us to deliver a change, right? So how do we drop the cost of change and increase the speed of finding out whether it's the right change or not? And then start tracking metrics around that. And then start educating people on some of the leading indicators of those, because those can take a while to collect. But what are some of the leading indicators that indicate that we're improving, that we will be improving those metrics, and educate them on that? And then spend a lot of work on educating them on how not to weaponize those metrics to beat teams up and how to use them as health indicators instead of you're a bad person. Because that is a huge problem.
What are some of the specific metrics you've used?
So the leading indicators so one of the jobs I had before I left there was, like I said, teaching other teams how to do this. And so the leading indicators my team would use was how frequently we can integrate code, We'd be looking at also like how long did it take to do a story or a task or whatever you want to call it, because we were pushing for 2 days or less as a forcing function to improve the quality of the information and the work. We were looking at reach. We'd be looking at the value stream map of what the process flow was and how many times rework was happening, where the rework was happening, what the wait times were in a value stream map. And we would be looking at defect rates. And because we always try to use a balanced set of metrics around size, speed, and quality so that you can't game offsetting metrics like that. We wanted those metrics to be gamed in a way that all of them improved. If we're faster with the same level of quality, cool. Well, at least we're faster. If we focus on speed and we don't look at quality, then quality is going to go down. If we only focus on quality, speed will go down. And how do we improve all of it? Because that takes engineering instead of just chasing numbers.
If you were to summarize the most common misconceptions or objections you've heard about CD, what would those be? I know you're very vocal on all of this.
CD just means that all we're doing is just throwing untested code down the thing. And I don't have time for my QA team to spend 2 weeks testing things. And so the quality is going to be terrible. It's just YOLO development, cowboy coding. It's not. It takes a lot of team discipline and quality discipline to execute continuous delivery if you follow the rules for continuous delivery. If you're doing some other thing where you're just throwing stuff down and we have a pipeline and we can deliver, and you're not doing all of the quality process and you call it continuous delivery, that doesn't mean continuous delivery bad. It just means that you can't read books.
So a lot of things that a lot of good practices that went wrong in the industry is basically the misunderstanding and misconceptions around them.
It's the way I started describing it was just disciplined software development. It takes a tremendous amount of team discipline to consistently break down work small, understand what the work is, be critical, kindly with each other's code, to make sure that we're reviewing each other's code, make sure that it's meeting our quality standards, that we're constantly looking at our test architecture and refactoring our test architecture for speed and performance and effectiveness all the time. I do that all the time on this stuff I'm working on now. I'll go in and say, I don't like this test. Let's see, how can we improve this test to make it more effective, less brittle, faster, all these things. You have to treat the tests better than you treat the code. And it just takes a lot of discipline to do that. And people just need to understand that signing up for that engineering discipline is what makes good engineers.
And a mindset switch that it's your job to actually focus on the quality. It's not something that you delegate to someone else.
Yeah. This whole concept, people think that it's normal to have this separation between engineering and quality, and that's not how my career started. That's a relatively new thing in my career, and it doesn't help anything to hand off to another set of people a set of requirements to test your code when I wrote a blog post called The Three Wrongs, where I talk about one of these three things is always wrong. Either the requirements are wrong, or we're going to misunderstand them when we're implementing them, or the need will change. The person asked for the wrong thing, or the actual need changed before we could deliver. And so what we have to do is deliver small things very quickly to get feedback to find out which one of those things is true so we can fix it. If I have a QA team and a development team, that second one, we're going to misunderstand them. We just doubled the odds of that happening. And then I've actually done value stream maps where I've measured this, where you've had a test team and a development team, where in the value stream map, they have a reconciliation process to find out whether the code's wrong or the test's wrong. And then sometimes they have to go back to the product owner to make a determination and then go through the value stream map again. It takes forever. If we just add the testing into the process instead of making a step like Toyota does, so things move, you get faster feedback on the actual quality. And quality isn't, it matches spec. Quality is meets need. It's fit for purpose. That's what quality is. And you can't find that out until you get in front of a user and find out.
And for CTOs or any engineering leader who is trying to implement this, they feel overwhelmed by everything that needs to be done to start with CD, what would be your final advice?
Every big problem is just a series of small problems.
Oh, I
Start
love
with
this.
it just is. There's no complicated software, and it's a bunch of simple software chained together into something complicated. This is the same. This is why we tried to break this down into do continuous integration. And we defined continuous integration, and we listed all the steps for continuous integration, which included trunk-based developments. What's trunk-based development? How do we do that? And so it's break it down into small problems. If I would start with a value stream map, look at how your team is delivering change. And if you're in a situation where we were in originally, where you have 400 developers on a 25 million line thing that's delivered as a thing, it's a big value stream map. You need to see where all the change is happening, and then start targeting the big rocks in that value stream where problems are. How do we fix this problem? And just then come down to the basics. Okay, all right, we have this problem we're going to fix. Let's decompose that problem until we get to some simple things that we can start working on. Start working on those. I always start with continuous integration. If I can't do CI, nothing else matters. CI is most of our quality process. So why can't we do continuous integration? Let's start looking at that hard and start fixing the problem. And don't make excuses. Don't say we can't because of this, and that's a reason. It's not a reason. It's an excuse. Just fix it.
I love how you start with the problem, like why can't we do this? And once you outline all of the issues, then you start just resolving them one by one until you get there.
That's literally what we did. And because we had such really good air cover at the VP level to try things out, we were working under SAFe at the time, which is very process heavy. And when I got on the team, I said, well, okay, here's the rules. Number one, there's no process at all unless it adds value to what we're trying to do. We'll start with no process. Let's go from there. And then we started adding processes, and we would try experiments. And if this experiment was good, we'd add that to our process to deliver. It made all the people really unhappy. We had a lot of really unhappy, scrum masters. Didn't care. I had enough air cover that I could just go, I'm sorry, we're doing it our way.
This is a great way to wrap it up. Thank you, Bryan, once again. It was an amazing discussion, a lot of great insights. I hope everyone picks something up from it.
Yeah, and people should feel free to reach out to me. I sometimes come across as curmudgeonly online, but I'm actually a really nice guy who really wants to help people deliver software better. I've had too many late night pager calls, and nobody else should have to do that. So I want to help.
And we'll add links to your pages in the resources when we publish this, so everyone can reach out.
Yep.
Thank you once again.
Thanks so much.
CTO Insights is brought to you by Adiva. To learn more about how we support innovative tech teams, visit adiva.it. Don't forget to subscribe to CTO Insights on YouTube, Apple Podcasts, Spotify, Substack, or wherever you listen to podcasts. Thanks for tuning in.